The volume of a sphere. Unfortunately, I can't completely develop the formula for this without using calculus. However, I can start part way in and then develop the rest of it for you. Okay, so here's a fact. The volume of a sphere is 2/3 the volume of a cylinder with the same height and radius. In other words, we were comparing a sphere to the perfectly designed container that would be a cylinder. Okay, the height of that cylinder is going to be the same height as the sphere. The width of it is going to be the same width as the sphere. And it ends up that the sphere is going to take up 2/3 of the volume of that cylinder. So from there, I can develop the formula. Okay, we'll be looking at the volume of the sphere being 2/3 the volume of the cylinder, which can be calculated using pi r squared, the area of the base, multiplied by the height of the cylinder. But our objective here is to actually write a formula which is based solely on the sphere. And there's only one dimension in the sphere that's important. And that would be the radius. So as I look at what I got here, there's one thing that doesn't quite make sense with respect to the sphere, which is the height, because the height is actually the height of the cylinder. However, the height of the cylinder is also equal to the diameter of the sphere, which is 2r. So I can substitute that in for the h. And with a little bit of algebra, I can move some things around. I can multiply the 2 by the 2/3, which is going to be 4/3. We'll keep the pi. Then r squared times r is going to give us r cubed. And that'll be the volume formula for a sphere. All right, example 1, let's go ahead and calculate the volume of this sphere. The one dimension that has been provided for us is going to be the diameter. The diameter is 12 centimeters. However, our formula is going to be based off of the radius. Okay, so the radius is going to be 6. So we're going to take v equals 4/3 pi 6 cubed. And that's it. That's really all you got to do to calculate the volume of a sphere. Okay, now in some cases, the volume of a sphere, or maybe the surface area of a sphere, different figures that involve this roundness to them, definitely the sphere type shapes though, we can write those answers in terms of pi, which means that we multiply the fraction by the 6 cubed and then we just leave the pi symbol at the end of it. So I'm going to show you that first. I'm going to start with the 6 cubed, which is going to give me 216. And the reason I start with that is because 6 is divisible by 3. So as my next step, I'm going to divide by 3, and after that multiply by the 4, which is going to give me 288. So the volume can be expressed as 288 pi. And you'll see that done a lot. Okay, the units for this would be centimeters cubed. You'll see the volume of the sphere commonly stated like that if the problem begins with a volume and you're asked to figure out what the radius would be, or the diameter, or possibly the circumference, because it allows us to divide out that pi at the very beginning and then creates these whole value numbers. Okay, now as a decimal, you can still evaluate it. I'll just multiply by pi. Okay, so this is the same thing as 904.8 centimeters cubed. Okay, so both answers are good. Example 2. What is the circumference of the largest cross-section of a sphere with a volume of 972 pi centimeters cubed? Okay, as mentioned before, you'll sometimes be given the volume in terms of pi. And the reason for that is so that when you do your calculations, you can actually just divide out the pi symbol. All right, for this particular problem, we're looking for the circumference of the largest possible cross-section of the sphere. The largest possible cross-section is going to be going through the center. It has to go directly through the center of the sphere. Okay, so then that circumference is going to be based off of the same radius as the sphere. So what we're going to do is take the volume, the 972 pi, and solve for the radius of the sphere. So we're going to set that equal to 4/3 pi r cubed. Once we get our radius, we can then plug it into the circumference formula and get the circumference of the largest cross-section. So from the very beginning, what you can do is just cancel out the pi. Okay, and then next we're gonna need to undo the 4/3. Okay, and to do that, what I tend to do is just multiply that number by the denominator, then divide by the numerator. In which case I'm gonna use a calculator because I can't do that as mental math. So I'm gonna take 972, multiply that by 3, divide it by 4, which will give me 729. So 729 is going to be equal to the radius cubed. So cube root it, and you get 9. The radius is equal to 9. So then take that radius to the circumference formula, the whole point is to plug in a number. Okay, that becomes an 18, so you get 18 pi, but 18 times pi is going to be 56.55, and that would be in centimeters. Volume is cubic units, but circumference is just a distance, so it'll use the regular units.
Wait, what?